Hello, and welcome to some online lectures for MA 106, Tech Math 2, one of the top two tech math courses run at BFIT. I'm going to talk us through some of the stuff from Skill 12. I'm going to talk us through the first part of the section, and then I'm going to sort of talk us through one of the homework examples, and of course, one of the examples from the book. I'm not going to read everything in this paragraph explicitly. This is all just sort of from the text. You can kind of have that up. I'll sort of do my usual thing where I kind of give a little bit of a rundown in my own words and explain what's going on. Skill 12 is all about some more formulas. We've sort of done different formula things before. We're sort of adding a couple new ones in here. The first one is about horsepower loss at elevation. The concept here, right, is of course the engine runs on explosions, right, on combustion. And so to have a good explosion, to have a good combustion, you're going to need oxygen. And what happens as you get to a higher and a higher elevation, what people say is they say the air gets thinner. What they really mean by that is there's less oxygen in the air. So the thinness is there's just less oxygen. If you've ever gone hiking sort of high up into a mountain, or if you ever fly into a place that sort of is at a higher elevation just sort of naturally, so a place like Colorado in Denver, or Utah or something is sort of up in the mountains, and so what happens is sort of when you step off, it actually is a little bit tougher to breathe. You kind of don't get as much oxygen for every breath, and so it can take a little while to what we sort of acclimate, kind of get used to it. So this is sort of true for human bodies. It is also true for cars and engines. Not that an engine is going to quote unquote get used to it, of course, but an engine is affected by having less oxygen up there. So it's going to actually affect the horsepower. It's going to make the engine less powerful because there's not as much oxygen in the engine to sort of give you as sort of effective a combustion. In any event, the sort of basic drop is you're going to lose about 3% of your horsepower for every 1,000 feet you go up in elevation. Sort of put into a formula, what we end up here is your horsepower loss, right? The HP loss. So that's how much your horsepower is going to drop by. So it would be 0.03, that's our 3%, times whatever the elevation is divided by 1,000, right? So for every sort of 1,000 feet you go up, you're going to lose 3%. So 0.03, right, is our percentage, times the elevation divided by 1,000, times whatever our original sort of horsepower is at sea level, right? So you're going to need some sort of baseline horsepower to be able to kind of do this calculation. You'll sort of say, okay, so what's my sort of quote unquote normal horsepower at sea level? So as we go up, it's going to sort of drop by 3% for every 1,000 feet. If we sort of look at the example in the book, I'll sort of talk us through this, and then I'll talk us through one from the homework section as well. So a certain type of car engine produces 190 horsepower at sea level. What is the power loss when the vehicle is driven at an elevation of 5,280 feet? So that's the elevation of Denver, Colorado, the Mile High City, right? 5,280 is 1 mile. What is the actual horsepower of the engine in this location? Right, so we've gone up 5,000 plus feet, so we're going to expect a drop. We're going to expect, 3% for every 1,000 feet. So this would kind of roughly be a 15% decrease. So the idea is we just sort of start with the formula, right? We've got it here. As we start to sort of sub in the information that we know, right? What we know is the elevation, the new elevation is 5,280, right? Up here, that's our elevation in Colorado. The original horsepower, the horsepower at sea level, is 190 horses worth of power. So 190 is here, right? 5,280 over 1,000. This is essentially just sort of the information, in what would be the nicest possible way, right? We're just sort of given the information we need. We can sort of find the horsepower drop. If we sort of start to crunch this stuff, if you do a division by 1,000, 5,280 becomes 5.28. We'll just do a quick kind of multiply, and we're going to end up at about 30 horsepower. This is sort of rounded just a little bit, but the idea is the horsepower loss will be 30. So that's not the new horsepower, right? We're not dropping all the way from 190 to 30. This is just that we're going to drop by 30. So the actual new horsepower is just a quick little subtraction, right? You're just going to do the original 190 minus the 30 that we're dropping, and of course that would leave us at 160. So if we have a baseline horsepower, and then from there we sort of know what the elevation increase is, we can essentially just sort of run this formula in order and get to our answer like that. I want to look at from the homework section. So you guys are going to be doing the evens for homework. So I'm going to look at number 5 here, which is one of the odds. You can see sort of 1 and 3 are very similar to the example that we just sort of talked through from the book. You can, as always, sort of take these questions and you can sort of ask them in a little bit of a different order, right? So in 2.5, we have a car that produces 190 horsepower at sea level. Just a coincidence that we're using 190 again. And then during a recent road trip, we discovered that the car is only producing 175 horsepower. So what was the elevation that you're driving at? So if you sort of know your normal horsepower at sea level is 190, and then you sort of discover while driving that your power has dropped to 175, you can essentially reverse engineer your way using our formula to figure out what the elevation is that we're driving at. So let's run through this a little bit. The idea, if we just sort of get a baseline right, so the horsepower at sea level is 190. The horsepower at elevation is 175, right? So what we need to know for the formula is what was the horsepower loss. So just a quick subtraction to find that, right? 190 minus the 175. So that's going to get us the drop. That obviously would just be a drop by 15. So the horsepower loss is 15. We kind of started at 190 and we dropped by 15. So if we're trying to find the elevation, what we're going to do is sort of set up our normal formula, right? So the horsepower loss should be 0.03 times the elevation over 1,000 times the horsepower at sea level. So we know, in this case, the loss, and we know the horsepower at sea level, right? And we're going to try to solve for the elevation. So we're sort of having to redo this formula just a little bit. If we sort of plug in what we know, so the loss is 15, the horsepower at sea level is 190, and then the elevation in purple is what we're trying to solve for. I'm trying to figure out how many feet of elevation we're at. What we can do mathematically here is we can kind of just rearrange some of these numbers a little bit. I'm just sort of rearranging and sort of getting the elevation out on the side. So this would really be the same thing as sort of a 0.03, divide by 1,000, and then times the 190. We can kind of crunch all those numbers on the right just at one time. That would get us essentially to the decimal point 0057. So 15, which is the loss, should be 0057 times our elevation. Right, once we can get all those numbers crunched to a single value, then we can just divide both sides by the point 0057. Right, so the idea is I can just sort of take the numbers I'm given, combine them all together, and then just do a quick division over on the other side. 15 divided by 0.0057. If I divide by a pretty tiny number, pretty tiny decimal number, it's going to give me a big value. That's what we would expect here, right? The elevation, we're talking about, a 3% drop for every 1,000 feet. So in this case, you're going to expect your elevation to go up sort of in the thousands, unless your horsepower drop is just a very small amount. So it looks like to us the elevation, if we have this sort of 15 horsepower drop, that's going to get us an equivalent of 2,632 feet of elevation. So kind of halfway. I guess that makes sense if we think of the example we did earlier in the video from the book, also had 190 as a baseline, and then that was 5,280 as an elevation, and that was a 30 horsepower drop. This is essentially half as much drop, right? 15, so we sort of get half as much elevation for around 2,600. in any event, that's the basics with the horsepower loss. We sort of have this formula as a reference. You know, you could do a couple different variations on this. But that's the setup. There you go.